Here we got some function operations. So we've got two functions to find f and g. We want to have an input of 10 into both f and g and then do the operation on them. So we're going to do an operation of subtraction on the two functions. So 10 will go into both of them and then just subtract the two values. All right, and so I'm actually going to do this on a calculator because I want to make sure that I'm careful. And so I'm going to go ahead, clear all of that. And I'm going to go ahead and it looks like it's f minus g. So let's get the f of 10 first. So it's f of 10 minus g of 10. That's really what you got going here. All right. All right. So let's figure out what f of 10 is first. F of 10, negative 40 plus 3. I can do that in my head actually. That's going to be negative 37 minus this. Now negative 10. I'm sorry, positive 10 is 100. That's a negative 100 minus negative 100 minus 10 is negative 110 minus negative 1. Yes, I don't trust myself. All right, try negative. Okay, 100, right? Okay, then minus 10. That's negative 110, okay? So minus a negative 110 is a positive 110. So, okay, there we go. My paper kept moving up. So negative 37, I do not trust myself with addition. So that's 73, okay, positive 73. All right, ooh, that's tricky. All those negative signs. All right, so now we're going 0, and our operation is just going to add them. And actually, I can do that in my head pretty quickly because g of 0 plus f of 0 means that the 0 gets plugged into the function, and g gets plugged into the f function, and then you get those outputs, add them together, and it looks like 0, that's going to produce 3. 0 here would produce a 5, so 5 plus 3 is just 8. You don't have to worry about extraneous solutions either because it's function operations. All right? You're not dividing possibly by 0, or you're not possibly taking the square root of a negative number. That's the thing. Those are the things that produce issues. All right, now we have function composition. This is super important because it happens so much in the future. And what we want to do is we want to plug the negative t into f first. Then whatever that is, that gets put into g. So we're going to be real careful here because our input is not a number, it's a variable. So let's watch what happens when we plug in an f of negative t. It means that negative 3, and I put a window here, okay? Remember the t, the variable here, gets replaced by the new input. Now it just so happens that this new input is also t, but it's negative. And so what you do is you just open up the valve here for that new input. Okay, it's almost the same, but he's just negative. Now that produces a double negative, which makes a positive 3t. So that's what this guy does to this particular function. So now I got a 3t minus 1. Now that is the output of the f function. This guy now has to go into the g function. So the g of 3t minus 1 will look like this. Open up the valve, and all you do is you add 4. Okay, a g function takes an input and just adds 4. So now I'm going to take that 3t minus 1 and just put him into that valve, and I end up with a 3t minus 1 plus 4, which is 3t plus 3, which is b. All right, same process here, but now you've got an n squared goes into the g function first. So g of n squared equals 4 valve open. Okay, and I just put in the n squared. Cool, no big deal. That actually ends up being 4n minus 1. All right, that's the output of the g function. Now, because it's composition, this guy goes into the f function, and f of this new function gets put into that n right there. So we get a 2. We'll open up the valve, and then we're going to go ahead and have gets multiplied by 2, subtract 2 from it. So let's open up the valve for the 4n squared minus 1 and do normal algebra. The 2 gets distributed for an 8n squared minus 2, but then you also got the minus 2 at the end. So you end up with an 8n squared minus 4, which is actually A. All right, now we're getting into the exponential growth and decay. And so let's just set these up. A new social media site is increasing its user base by approximately 3% per month. If the site currently has that many users, what will the approximate user base be 7 months from now? So what you got to remember is that the basic function is your initial value, and you either add or subtract the rate, and you raise it to usually time. Okay. We've written this in different ways, right? Sometimes instead of a lowercase a, we put a p. So instead of a y, sometimes we had a capital A. So there's many different ways to write this, but the basic part is the same. We know it's a growth, so we start off with, let's switch it up. Maybe this looks a little bit familiar to you. If you had 38,310 people starting off with, you are going to increase it by 3%, and you're going to do that for 7 months. Okay, that's all that the setup is. I'm going to straight up use my calculator here. 38,310, 1.03. That is the growth of 3%. That is getting raised to 7 months. And we got 47,116. We're going to round to the nearest person. That is B. All right, same thing here. Where it's compounded annually. Well, that's the easy one. We're not, like, compounded annually means it only happens once. All right, so that's great. So we're going to start off with 1,511. It's going to go up. So 1,511. It's going to go up by 2%. And we're going to go from 9 years because it's doing it annually. All right, so that setup is all ready to go. 9. Okay, so 1,805 and 0.78. Since we're dealing with money, we can go to the nearest penny. That would be the answer there. All right, keyword here is reduction by 5%. And that's CO2 emissions. If the emissions are this, what is the maximum allowable emissions? If you're supposed to be reducing it by 5% each year, what will happen 8 years from now? So we are going to start off with 5,090 metric megatons, and that has to decrease by 5% every year until 2030. That's 8 years from now. All right, so that is our setup. So again, go back to the calculator. This is all in the setup. All right, now 1 minus 5% is actually 0.95%. Okay, that means that after every time period, I'm left with 95% of my original value. That is decay. All right, so I should have, I'm going to round up to the nearest megaton, metric megaton. So that would be 3,377. And then finally, a rubber bouncy ball is dropped from a height of 200 centimeters. After each bounce, the ball returns to a height that is 15% less. So it drops 15% of its maximum height every time. And so we can actually calculate what should happen after the 8th bounce. Okay, so a rubber bouncy ball starting off at 200, all right, is going to drop 15%, which means you only have 85% left every time this happens for every bounce. And after the 8th bounce, we're going to raise that to the 8th power. So that's 200. You only have 85% every time. That's going to be 54.5 centimeters. Okay, and again, those are just straight up calculator problems. We'll use the sample logs for the next one.